all the trees high up, baby.
Hey guys!
Welcome back to AP Bio with Kahveh,
Hannah, and Maya. And today we're going to explain the Hardy-Weinberg equation and theorem.
Yes!
How can we get non-changing allele frequencies in a population?
You need to remove all factors of evolutionary change in the environment.
What are those factors?
I don't know. Let's ask the expert.
Hi, that's me, the expert. 1. There must be a large population size with no genetic drift. 2. There cannot be any migration or gene flow. 3. There cannot be any natural selection. 4. There cannot be any mutations or genetic change. And 5. There must be random mating and no sexual selection. Look what I found, p squared. Did you know p squared is the percentage of homozygous dominant individuals in a population? Brazy, am I right? Now let's look for 2pq and q squared. Come on!
So much work to do. 2pq, what are you doing here? Speaking of 2pq, 2pq is the percentage of heterozygous individuals in a population. Now we have to find q squared. Follow me.
Q squared, you silly goose. We've been looking everywhere for you. Q squared is the percentage of recessive individuals in a population.
The Hardy-Weinberg equation can be used to find the frequency of genes in a population. The genes in a population make up the gene pool. P is the frequency of dominant allele, and then Q is the frequency of the recessive allele. P plus Q equals 1. Let's try a problem together. You have sampled a population of dogs in which you know that the percentage of the homozygous recessive genotype, small a, is 36%. Using this, calculate the frequencies of small a, big A, big A, big A, and big A, small a.
Like mentioned earlier, the two equations you need to know for Hardy-Weinberg are p squared plus 2pq plus q squared equals 1 and p plus q equals 1.
So using this, we can identify that the given 36% is q squared, and we can take the square root of this and find that q is equal to 0.6. The q squared is equal to the genotype small a, and by finding q, we were able to find the allele small a.
Okay, and now that we have q, we are able to find p. Because p plus q equals 1, we can subtract the value of q, which is 0.6, and find that p equals 0.4. So p is equal to the allele big A. And then from here, we can square this value and find that p squared, the homozygous dominant genotype, is 0.16. After finding p squared, we had found the genotype big A, big A.
Now that we have the values of both p and q, we can find the heterozygous frequency using 2pq. We multiply 0.4 and 0.6 and 2 to find that the heterozygous frequency is 0.48.
Now that we've found this number, we've found all of the heterozygous and homozygous gene and allele frequencies.
Now here's a problem that you guys can try at home. Remember that the only equations that you really need are p squared plus 2pq plus q squared equals 1 and p plus q equals 1.
Hope that was helpful!